Okay, hi class. This is your day 3 lesson for AP Chemistry, and this is Mr. Mellinger, and so we're going to get into our first lesson in chemistry. What is chemistry? Well, everything in the universe can be divided into two things. There's matter, which we kind of just call stuff, and that's anything that we can touch or hold. Technically, matter is anything with volume. It takes up space, and mass, that is, it has matter inside of it. Or it has mass to it. It can actually be weighed on a scale. Energy is what causes matter to move or change. So if you have a ball sitting on a table and you pick it up and throw it, while it's flying through the air and it's in motion, it has something in it that's causing it to move, and that something is energy. Similarly, if you took a match and lit the match to the ball and caused it to burn, that would be putting energy into the ball. That would be causing a chemical change. The ball wouldn't be moving anywhere, but it would be changing. So that's what energy is. Now, there's all kinds of energy. Physics is interested in different forms of energy. There's light energy, electrical energy, there's heat energy, sound energy, mechanical energy. That's throwing a ball is called mechanical energy. And these things all seem totally different from each other, but what they have in common is they're all forms of energy. And since they're all the same thing, they can all be converted from one form to another. So electrical energy can be converted into light energy, or electrical energy can go into an electric fan to make the fan turn around, and that's converting electrical to mechanical energy. So one of the beautiful things about all these different forms of energy is they can be interconverted from one form to another. By contrast, chemistry is interested in matter and what things are made of. So one of the real fundamental principles of chemistry is electromagnetic force. The electromagnetic force is a force of nature, just as gravity is a force of nature. The key point to remember about electrical force is that positive attracts negative and negative attracts positive. Positive repels, pushes away other positives, and negative repels negative. So you can see a diagram down in the bottom. So if the charges are the same, they'll push away from each other, and if they're different, positive, negative, they'll attract to each other. And that's really a fundamental principle of chemistry that you'll be dealing with every single day in this class. All right, so what is an element? An element is pure matter that cannot be divided into simpler substances. How many elements are there? There's 92 naturally occurring elements, plus about another 20 or so that were created by scientists in laboratories. All matter in the universe is made up of these 92 elements. We know every element that's in the universe without exception. Now, how can everything be made up of only 92 elements? Because in the classroom by itself, there's probably 10,000 different substances in the classroom. Well, just as 26 letters of the English language can be arranged to make millions of words, it should be 92 elements can be arranged to and combined to make millions of different substances called compounds. A compound is a substance containing two or more elements. All right, so this is the periodic table. It lists every element in the universe. The first 92 leading up to uranium, U down there on the bottom row, are the natural elements. Everything after that are man-made elements. Now you're going to learn why all these different colors exist and what they represent. You're also going to learn why the periodic table has the shape that it does. And you'll learn all that in the next week or two. All right, so what is an atom? An atom is the smallest piece of an element that there is. If you cut an atom of gold or iron in half, you will no longer have gold or iron. The ancient Greeks, thousands of years ago, had what then was just a philosophical debate because they didn't have a way to prove this. If you took a piece of gold and cut it in half, then took a piece of that and cut it in half, and then a piece of that and cut it in half, could you at least in theory go on and cut it forever if you had a small enough knife? Or do you finally get down to a smallest piece of gold? And they believed that there was a smallest piece of gold. And they called that atomos, meaning indivisible. And so that's where the word atom comes from. What are the three parts of an atom? An atom consists of three components. Protons have positive charges. Neutrons have no charge, and electrons have negative charges. So let's look at the structure of an atom. So if you see in the center there's a green kind of a circle, and that's the nucleus. And the nucleus contains protons, positive charges, and neutrons, neutral charges. Now, the nucleus, unlike what you saw in biology, where the nucleus had a membrane around it, it was kind of in a pouch, that's not true in an atom. It's just that green area is just shown to represent the nucleus, but there's not really a sac or a pouch around the protons and the neutrons. Around the outside of the nucleus, you see a circle, and that circle is an orbital. An orbital represents an energy level, and electrons travel in orbitals. So the electrons are the negative charges, and they're flying around the outside of the atom, whereas the protons in the middle are the positive charges that attract the negative charges and keep them from flying away. Now, the orbitals, as I say, represent energy levels, and there's different energy levels, a first orbital, a second, a third. You can almost think of them like train tracks. Electrons can only travel on an orbital. Just like a train, if there are two sets of train tracks, the train either has to be on one set of tracks or the other. It can't travel in between them. So the electrons go. Now these go on the orbitals. Now the orbitals are not perfectly round. About 100 years ago, that's what they thought they were when they first came up with this orbital theory, that they were these round circles. They're not. But we still can do a lot of chemistry by representing them as round circles. All right. What is a valence orbital? And this is a very important term. Commit this term to memory quickly. A valence orbital is the outermost orbital of an atom, and the electrons in the valence orbital are called the valence electrons. The word valence simply means outermost. So because helium has only one orbital, this is the valence orbital. It is the valence electrons that form chemical bonds. That's why they are so important. They're the ones that are out there connecting with other atoms to form chemical bonds to make substances, is the valence electrons. Okay, so let's look at on the periodic table, a simple periodic table. You'll see four elements. For each element, you'll see four different parts. So the atomic number, that's the number at the top on most periodic tables. This is the number of protons that an element has. It is also the number of electrons that an element has in its electrically neutral state. We'll define that on the next slide. So this is a very key point to remember. Of protons, neutrons, and electrons, it's the number of protons is what determines an element's identity. For example, hydrogen must have one proton. Lithium must have 3 protons. Lithium could have, different lithium atoms could have different numbers of electrons or different numbers of neutrons, but if it's going to be lithium, it has to have 3 protons. So it's the number of protons that defines what type of element we're dealing with. All right, now the next thing down you see is the H. That's simply the abbreviation for the element. It's called the atomic symbol or element symbol. Next under that is just simply the name of the element. In this case, it's hydrogen. And finally, the mass or weight of the element, of one atom of the element, is represented down there as the average mass or weight of the element. The reason that it's a decimal number we'll talk about at a later time. Okay, so now we're going to go into talking about what is an atomic mass unit. And the mass that you saw in that last slide, the 1.01, is the atomic mass. It's measured in atomic mass units. So what is an atomic mass unit? An atomic mass unit is formally defined as 1/12 of the mass of a carbon-12 atom, which has a total of 12 protons and 12 neutrons. This is a definition, other than maybe asking you one time on a test, you'll never be tested on again. They won't even ask you this on an AP exam, but you should understand where an atomic mass unit comes from. So down at the bottom there, you see the nucleus of a carbon atom. So the carbon has a total of 12 protons and neutrons. You count them there. 1/12 of that mass of carbon is about the mass of 1 proton or 1 neutron. So we can think of an atomic mass unit as the mass of a single proton or a single neutron. And that's the way we're going to think about it. We're not going to worry about this 1/12 of a carbon atom definition. It's just a proton has a mass of 1 atomic mass unit. A neutron has a mass of 1 atomic mass unit. Okay, so we can think of an atomic mass unit as the mass of a single proton or a single neutron. Since the atomic mass of each proton and neutron is 1, an element's atomic mass number tells us how many total protons or neutrons one atom has. Think about that for a second. If carbon-12 has an atomic mass of 12, and then each proton it must have a total of 12 protons and neutrons combined. So we may not know how many are protons and how many are neutrons, but it could be 8 protons and 4 neutrons. It could be 6 protons and 6 neutrons. It could be 1 proton and 11 neutrons. But that number has to add up because each one of those has an atomic mass of 1. And we know that the total mass of the carbon atom is 12. So those two numbers have to add up to 12. Okay, so what does electrically neutral mean? Electrically neutral means that an atom has the same number of protons, positive charges, as electrons, negative charges. Okay, so the same number of positive and negative charges means that the atom is balanced electrically. For every positive charge, we have a negative charge that it's attracted to. We use the term electrically neutral to indicate that an atom has no net electrical charge. If, for example, an atom had one more electron than proton, it would have a net negative charge because there would be one more negative than positive. Similarly, if it had one less electron than proton, it would have a net positive charge. But it has equal numbers of protons and electrons, then it has no net electrical charge. All right, so now we're going to learn how to use the periodic table to diagram an atom. So we're going to first start with the simplest element, that's hydrogen. And over on the left, you see a scoreboard. And that's simply where we're going to keep track of how many protons, how many electrons, how many neutrons, how many orbitals it has, that atom, and how many electrons in the outer orbital. Those are the valence electrons we talked about earlier. And those are the ones that are really important. Sometimes that's the only thing we want to know about an atom, is how many valence electrons it has, because those are the ones that do the chemical bonding. So first, hydrogen has an atomic number of 1. So if it is electrically neutral, it must have 1 proton and 1 electron. So the 1 tells us how many protons, and in its natural state, hydrogen will be electrically neutral, so it will also have 1 electron. So there we go. So we fill in those two places on our scoreboard. The other thing we can then do is go ahead and place that proton in the nucleus. The nucleus here is rectangular so as not to get it confused with the orbitals, which are circular. Okay, so we're going to take the electron that we know we have, and we're going to stick that off to the side right now. All right, next thing we want to do. Now we round the atomic mass to the nearest whole number. And we will explain why, that is a decimal number later on. But for right now, we're going to round 1.01 down to 1. So you see that just happened. And that's called the mass number of the atom. So what do we know? What did we say we know from that number? That number tells us the total number of, if we add all the protons and neutrons in this atom together, it's going to be 1. Okay, it's going to be 1. I'm sorry. Okay, so the mass number tells us the total number of protons and neutrons added together. We can now use this figure to figure out how many neutrons there are. We already know there's 1 proton, so let's figure out how many neutrons. So we're going to do a little arithmetic here. The mass number tells us the total number of protons and neutrons. And we know we get that number down there at the bottom, right below the word hydrogen. And we know that number is 1. The atomic number, check that. The atomic number is this number up on the top, and that's the number of protons. So we're going to put that number right here. So if we take the mass number and subtract from that the atomic number, then that is going to give us the number of neutrons, and that is 0. Okay, So we know that we have a total of 1 proton and neutron, and we know that that is a proton. We see it right there in the nucleus. So if we subtract that, then that tells us we have no neutrons in a hydrogen atom. So we're going to go ahead and fill in our scoreboard here. And there's neutrons, and there we see we have 0 neutrons. Okay, let's keep moving on here. Now we're going to figure out how many orbitals. So because hydrogen is in the first period or row of the periodic table, and we'll talk about the periodic table in a lot of detail, but the first row of the periodic table where you just see hydrogen and helium, that's called the period. It only has, if it's in the first row, it only has 1 orbital. That means hydrogen and helium have only 1 orbital. So we're going to go ahead and fill in our scoreboard right there. So orbitals is 1. Now, hydrogen is in the first column of the periodic table, and the columns of periodic table are referred to as groups, but you can use the 2 words interchangeably. Anything in the first column, so you can see hydrogen, lithium, sodium, they have 1 valence electron. So the group that it's in, or the column that it's in, tells you how many valence electrons. So we're going to go ahead and finish our scoreboard down there. The electrons in the valence outer orbital is going to be 1. So now we can draw our hydrogen atom. We know it has a proton in the nucleus. It has 1 orbital because it's in the first row, and it has 1 valence electron. That's the only electron it has in its valence orbital, and that's how you draw a hydrogen atom. 1 proton, 1 electron. Okay, let's go on to the next one. And we're going to just move 1 up on the periodic table, so we're going to go to helium. So find helium on your periodic table. So first, helium has an atomic number of 2. So it must have 2 protons. If helium is electrically neutral, it must also have 2 electrons. So right away we can fill in those the first two parts of our scoreboard there. Okay? And now we can also put the protons inside of the nucleus. So there they are, those 2 plus charges. All right. And we're going to take the electrons for right now and just put them off to the side. All right, now we round the atomic mass to the nearest whole number. So see the 4.003, we round that, and that's going to be called the mass number. So that's going to be rounded to 4. So again, what does that number tell us? The 4 tells us the total number of protons and neutrons added together that we have in a helium atom. So the atomic mass number, the mass number, tells us the total number of protons and neutrons added together, and we can use this to figure out how many neutrons there are. So we're going to do that the same way we did with the hydrogen atom. So let's just do a little arithmetic. The atomic mass or mass number is the number of protons and neutrons added together. Okay, and there you see it down there. It's the 4. So we're going to put a 4 right there. Then the atomic number is going to tell us how many of those are protons, and we already know that. We know that there are 2 protons in the nucleus. So if we take the 4 of the mass number and subtract the 2 of the atomic number, it gives us a final answer of 2. 4 minus 2 is 2. That means that's how many neutrons we have. 2 neutrons plus 2 protons gives us a total of 4 protons and neutrons a total of 4 protons and neutrons. So now we can fill in that area of our scoreboard. So we put a 4 next to neutrons, and now we can also add those neutrons into the nucleus. So you see the little equal signs going into the nucleus, and now our nucleus is complete with 2 protons and 2 neutrons. All right, now what row is helium in? We need to figure out how many orbitals. Well, because helium is in the first period row, again, the word period and row is interchangeable here, it has 1 orbital. First period, 1 orbital. Second period, 2 orbitals, and so on. Okay, we'll get to that in a minute. All right, so that means we can fill in our orbital number down there on the scoreboard, and it has one orbital. Finally, we want to know how many electrons are in the valence or outer orbital. So we see that it's the second element in the first period. Don't worry about all those elements down below. They're not in the first period. They're in the second, third, fourth. But helium is the second element over in its row or period, and therefore it has 2 valence electrons. So we can fill in that. The electrons in the valence or outer orbital is 2, and we've completed our scoreboard. So now we can draw our helium atom. It has 1 orbital. That's the valence orbital, and it has 2 electrons in that valence orbital. So there are 2 elements in the first period row, so the first orbital can hold 2 electrons, and now it's full. Okay, we're done with the first row. It can't hold any more electrons because helium is at the end of the first row, and so there's no more vacancy in that orbital. We can't put any more electrons into that first orbital. Okay, so that's how you take care of that. That's how you do helium. Let's do a couple of more. Now we're going to skip lithium. Let's just go to beryllium right now, okay? So you see in the upper left-hand corner the atomic number and atomic mass for beryllium. So let's go ahead, and you notice in the nucleus now I just put protons, neutrons. We're going to get to where we have so many circles with plus signs and equal signs it would get to be a little cumbersome. So we're just going to write down how many protons we have in the nucleus and how many neutrons rather than all those little circles with plus signs and little circles with equal signs. Okay, so here we go. Beryllium has an atomic number of 4. So it has 4 protons, and if it's electrically neutral, it also has 4 electrons. So we can fill in those first 2 slots on the scoreboard. And we can go ahead and let's just go ahead and put the protons in there as the number 4 rather than drawing all those circles. All right. So we're going to put the electrons off to the side for now. Okay, so here comes the 4 electrons. There they come. Okay, so 4 electrons off to the side for right now. Okay, next we want to figure out the number of neutrons. So we look up to the upper left-hand corner. We see beryllium has an atomic mass of 9.012. So we round the atomic mass to the nearest whole number. There we go. And there it is. So 9.012 rounds down to 9. So answer this question to yourself. What does that 9 tell us about protons and neutrons? It tells us that's the total number of protons and neutrons in the nucleus of a beryllium atom. So now we're going to do our arithmetic step here. So we can now we can calculate the number of neutrons by subtracting the atomic number from the atomic mass, or from the mass number technically. So atomic mass or mass number is protons and neutrons, and that's 9. Minus the atomic number, which is the number of protons, that's the 4. And if you do that subtraction, that'll give you the number of neutrons, which is 5. So there's a total atomic mass or mass number of 9. 4 of those 9 are protons and 5 are neutrons. So we can go ahead and fill in our scoreboard for neutrons, and we can also finish filling in our nucleus. So 4 protons and 5 neutrons. Now we're ready to move on and figure out the number of orbitals. So because beryllium is in the second period or second row, I'm just covering that whole row over in green to highlight where it is. Because it's in the second period or row, it has 2 orbitals. Second row, 2 orbitals. So we can fill in that on our scoreboard, and now we can draw those 2 orbitals, and there they come. And you notice we kind of draw them as concentric circles. Again, don't worry about what their real shape is at this point. We're going to just treat them as circles. So we have an inner orbital and an outer orbital, which is our valence orbital. All right, so now we get to place the electrons in the first orbital. The first orbital gets 2 electrons and then it's full. Remember we said that because hydrogen and helium, there's only 2 elements in the first row. That means the first orbital can only hold 2 electrons. Okay, now in some diagrams you'll see in books they'll spread the electrons out. I don't like to do that. I like to put them side by side. We'll get into this concept a little bit more later, but it tells me that those two electrons are married to each other. They're locked up. They can't pair with any other electrons. So now that we've put them there, the first orbital has no vacancy. You can't put any more electrons there. So what do we do with the final two? They go in the... What do you do with those final two electrons sitting there? The next two electrons are put in the second orbital, and we're going to space them out. Think of the circle as having four sides to it. So we're going to put one of the electrons there, and we're going to put one of the electrons there. The fact that they're spaced out means that they're unpaired. I'll jump ahead a little and tell you that what those electrons want to do is they want to pair up with other electrons to form bonds. And so the fact that they're unpaired means that think of them as being unmarried. So they can get married to an electron from another element and form a chemical bond. So those are our two electrons in the outer orbital, which is the valence orbital, which makes them the valence electron. So beryllium has two valence outer orbital electrons because it is the second element in its period row. I mean, we can see it from the diagram, but what if you didn't draw the entire diagram and you just wanted to know how many valence electrons that beryllium has? Well, there's the first element in the second row, and there's the second element in the second row, and so that tells us that we have two electrons in the valence orbital. Now, you know notice the periodic table, I kind of closed it together from what you see, but that's not important for us right now. The second row has those 8 elements from lithium all the way down to neon, and so we're just doing that to save some space here. Okay, so there you go. You filled in your scoreboard. And the electrons in the valence orbital, the outer orbital, there's 2 of them. There they are. We show them as unpaired, and that's it for beryllium. Okay, now we're going to jump way up. We're going all the way down to a element in the third row or third period. And you can see it's number 14, silicon. Again, we're not showing the big gap between the left side and the right side of the periodic table. We're just kind of squeezing it together, but that doesn't really matter. It's okay. Okay, so silicon, we see it has an atomic number of 14 and an atomic mass of 28.09. So give it a try. See if you can do this on your own. Okay, you want to constantly be challenging yourself to see if you can do this. You can pause the video for a few minutes. See if you can diagram this one on your own. Okay, so let's get started with this. So silicon has an atomic number of 14, so that means it has 14 protons and 14 electrons. So we fill in the first 2 slots on the scoreboard. We can also put the 14 protons into the nucleus. Okay, we're going to put the electrons off to the side for now, and there's a whole lot of them, and I'm just going to speed this process up, so boom. There's 14 electrons off to the side. We're going to figure out where they go in just a little bit. Okay, so here we go. Next thing we want to do is figure out the number of neutrons. So we take, what do? We now round the atomic mass to the nearest whole number and make it the mass number. So that 28.09, how does that round? It rounds to 28. Okay, so 28.09 rounds to 28. So what does that tell us? It tells us that we have a total, if you added them all up in silicon, you have a total of 28 protons and neutrons added together. So now we're going to do our arithmetic step here. Okay, so now we can calculate the number of neutrons by subtracting the atomic number from the atomic mass. So the atomic mass is the total number of protons and neutrons, okay, minus the atomic number, which we know is 14, is the total number of protons. And when you do that arithmetic, you end up with 14. They're not always the same, the number of protons and neutrons, but they're usually very close for the smaller elements. They're usually within 1 either way. So that means we can go ahead and fill in our scoreboard for neutrons, and that's going to be 14. And then we can go ahead also and put that 14 into the nucleus. So now our nucleus is complete, 14 protons and 14 neutrons. Now let's go on to orbitals. So which row is silicon in? So because silicon is in the third period row, it has 3 orbitals. So that everything that you see covered in green would have 3 orbitals because all of those 8 elements that you see there are in the third period or row. So here come the orbitals. Well, we'll fill in our scoreboard first with 3 orbitals. And here come the orbitals. There's 1, there's 2, and there's 3. Okay. All right. So now we're ready to start placing our electrons. So here we go. So now we get to place the electrons. The first orbital gets 2 electrons, and then it's full. So there's 1, and there's 2. And we put them next to each other. They're married, so they can't bond with any other electrons. Okay, now, what about the second orbital? How many can it hold, first of all? Well, if you look at the second row of the periodic table, it has 8 elements. Starting with lithium and going to neon, there's 8 elements. That means the second orbital can hold 8 electrons. So let's go ahead and place those. I'm going to show you how I'd like you to place those. By the way, first of all, okay, the first orbital has no vacancy. It can't fit any more than 2. Now we go to the second orbital, and we're going to place an electron there. Now we're going to spread the electrons out, because as long as they're spread out, as long as they're not paired up, they can bond with other electrons. Okay, so now we've put in our fourth one. Okay, now we can continue to put electrons in the second orbital because it can hold 8. Now notice that we start to pair them up. So those electrons cannot bond with anything from the outside. There's another one, and there's another one. So finally we filled the second orbital, so now it has no vacancy. The second orbital or row can hold 8 electrons. You know that because the second row of the periodic table has 8 elements in it, and each one contributes an electron until you fill up that second orbital. So now you can see we have 4 electrons left, so let's place them around in the same way. So we're going to put the first one here, we're going to spread out the second one, we're going to spread out the third one, and finally spread out the fourth one. So you can see that all 4 of those electrons, they could bond with electrons from other elements from the outside because they're not married. They're not paired up with another electron already. So those could be bonding electrons. And so how many valence electrons do we have? Well, those are the electrons in the outer orbital. There's 4 of them there. So we can fill in our scoreboard. So we know that silicon has 4 valence electrons because it is the 4th element in its row. So again, you might want to just know how many valence electrons silicon has without drawing this diagram. So you simply count how many positions over is silicon in the 3rd row. If you look at your periodic table, it's the 4th element over in the 3rd row. So that means it has 4 valence electrons. And there we show that right there. And so we've completed our scoreboard, and we have completely drawn our silicon atom. So that's it for silicon. Not too bad, is it? This process isn't too hard. Okay. All right, and I think that's an extra slide. And that's it. So that takes care of our introduction to atoms, elements, and how you construct an atom for an element based on where its position is in the periodic table. Okay, we'll see you in class.